All right. Working with you. There's some position for you. Looking forward to working out this position with you. Hello? Hello, can you hear me?
Yeah.
Hey, how you doing? Oh, what is that? Okay. Wait, I can't hear you. Can you hear me?
Yeah.
Okay. Yeah, I saw some like animal on your screen. I was like wondering what that was. How you doing today?
Good.
Okay. Yeah, like I heard that yeah, your dad was supposed to set this up. So like I sent him the link. So I'm glad that you guys worked that out. Yeah, like how was your week? Did you guys do anything new? Anything else new from last week or this week?
Not anything new from math.
Still the same thing, like what we did, kind
Yeah.
of. Oh, okay. Yeah, that seems like. I mean, how do you like the pace of your class?
Good.
Okay.
'Cause they don't teach us like a different thing every time.
Okay. And then were you able to? I guess did it help out that we practiced those problems?
Yeah.
Okay. Yeah. Like I think your mom was telling me maybe talk about a few things about have you I remember last time I kind of touched on like word problems for percentages, but we didn't really go over it because I think we didn't have enough time. But do you mind if we go over that today?
Sure.
Yeah, I know a lot of this I guess I'll preface it first, like in terms of like you're gonna be working with math like from now till like forever, right? Yeah, and then you might as well get a hang with like working with real world stuff. Oh, in essence, that's like what a world problem is. Like what we did like before last week, it was just a lot of like doing like strictly just math, like fractions, right? And then that's good to a certain extent, but it it's always twofold. Like you gotta know the math, like operations, as well as like applying it, right? So like if you get to a point where once you apply it, the math should kind of like come pretty like natural. But one of the hardest things I feel, like for me, when I was like learning math for the first time, one of those hardest things was like comprehending what the question was asking. It was always like, because with having a math problem, like what we did last week, like, oh, do this fraction, add this, right? Multiply. It's just like plain, like, okay, I'll do it. So now what? Like, what do you do with that, right? Like, but then with a word problem, it gives it kind of like this, I mean, in essence, like a fulfillment, like, because then it's not just numbers now. It's the numbers have units. But I gotta say though, like this was hard for me as well. Was it's always setting up the problem. It starts out easy, and then like it just progresses. Like in the beginning, I think it's good to create like a system, so that when things get hard, when the problem gets longer, when the math gets harder, that system can be, you could use that system all the time. I'm pretty sure you probably already do this naturally. It's like a problem solving technique where, like when you're set with something and then you want to solve it, you want to know what you have first, right? Like what do you have on the table, and then that's like the givens. Like, and it may seem pretty like, okay, I already knew that, but breaking it down like this will allow you to like kind of like frame the problem so that every single time you see like a word problem, like you're always going to be thinking in that sense so that it's easier for you to organize it. And the better you are at that, because every problem will just change depending on like the math will change, the assumptions will change, but it's always what do you have on the table, which is givens, and then what are you trying to find. After all those givens that you have, you kind of write them down. What is it that the question is asking you? And in the beginning, it's like very simple. And then the next thing, the third thing is, okay, now having to know the givens and what I'm trying to find, what is the procedure for me to solve the problem? And that can be like, using directly what you have from like a problem, or you have to manipulate something. And as the math like becomes very hard later on, you're gonna have to switch a lot of equations, combine a lot of equations. But now I guess we can start with this first one. This first one right here isn't that bad. It's like unit rates, percentages, and proportions. It's technically just putting like a story to what we've already been doing last week. And then the second one is just, yeah. Oh yeah. The I think I sent your mom all the worksheets. You can probably do those if you have time. I know you're really good at math. Like all the math we did last week, those are really good. And so I did add a few more things there. So maybe like every 2 weeks, I'll send you guys a new package, because a lot of this is just doing more. The more you do, like easy stuff is even if it's easy, I would do more of it because then when new concepts come in, um, sometimes you forget the easy stuff, and then you want to be able to relate those. Find like a relationship between what you did already and then what you're doing now, so that it's like, oh, it's pretty much the same thing. So okay, let's just talk about this first. All right. So do you remember doing the ratios last week, right? We kind of did like a over. I think this is it right here. Yeah, you did like a over b equals something, right?
Yeah.
Equals x, and x was the thing that you had to find, right? You had to find x, if you remember doing that. But then a, b, and this big B is like all numbers, right? So if you take a look at this, I'm just gonna like talk about the equation first, like we did last week, kind of like relating it. So remember, like I said, like you like now is you have to find what the givens are, right? Like what you have on the table. So if you look at this, what do you have on the table? You have a, small b, and big B, right? So those are the givens. You have that. It's in the equation. But then what are you trying to find? You're trying to find the x, right? And then what's the procedure? That's what we did, right? We did this. We cross multiply them. That was the procedure. Like you did like bx times small a times big B, right? And then x equals like small a big B divided by small b, right?
Yeah.
So that's the procedure. That's like, so yeah, you have the givens, you get, you determine what you're trying to find, and then you do the steps. So for a word problem, that's pretty much exactly the same thing. So let's just like, I guess maybe let's try to do one thing at a time. Maybe if we do like number one, maybe tell me first what you have for givens and what do you have to find, and then like what do you have to do. So for one,
12 red cards and 20 green cards.
those are givens. Okay. Let me just let me do this guy. Yep. Yeah. So the 12 red cards and 20 green cards. Yeah, that's givens. Yeah, that's definitely correct. And then what do you have to find?
What the ratio of his red cards to his green cards.
Okay. Perfect. So it's technically what we already did know, right? It's just there's words to it now. So what would you do? What would be the procedure? How would you set up the equation?
12 plus 20.
Okay. So yeah, you could do that. But like this one is okay. Let's step back. Because I had to actually explain this to stuff. When you're doing ratios, you could do relative ratio or total ratio, right? So like a relative ratio would be, let me just erase this 12 first. So a relative ratio, for example, for this is like red cards to green cards, right? Or you could do red plus green over, wait, hold on. Let me do that again. You could do red over red plus green, right?
Yeah.
And this would be a total ratio. Like it's like the part of it and over the total. But this problem is actually wanting you to do this, a relative ratio. It's like one item versus the other, not their total. So for this, like I would probably just do this first, specifically like 12 over 20. And then you do this equals, because it's a ratio. And then what is the x here? Is it the red?
Red.
Over.
Yeah. Red on over. Top.
I think this is x. This is the one we're trying to find. Yeah, it's asking you for the ratio. It's not asking you to find which one is which. So it's actually easier. So it's just this guy. And then what do we do? What do we do with the fraction? We just have to simplify it, right? We just simplify the fraction.
Yeah.
Does that make sense? Like that's the ratio. That's what it's asking you. Like the ratio of red to green. It's like a one-step problem, but just giving that to words, and now we have to like figure out the equation. All right. That wasn't that bad, but let's try do. I think the one that we were talking about is more similar to number 2. Let's try to do this one.
10.
Okay.
And then over 12.
All right. Yeah, that's good. Okay.
Equals 252 over x.
Let's see. It says 252 guess, right?
Yeah.
Okay. So what was a lot of times when I do this, I want to always give it some units, to make it make sense in the beginning. But once you're doing the math, you don't really need the units anymore. But what does this top mean? This is soft drinks, right? And this is guess, right?
Yeah.
So when you're doing the ratio for the other side, where do you put the guess, the 252?
On the denominator.
Yep. Okay. Yeah, that's good. And then, so where is the x here, right?
Yeah.
Okay. So this is exactly what we did here. I wanted it to look like something that we've been doing, and so this is exactly what we want. And then, so what do you do now?
252 times 10 over 12.
Okay, I'm just gonna move the decimal. Or like that?
Yeah.
And then you just do this, right? Just do the math. You know what you've been doing. For now, I guess we don't have to really do the math. Let's just try to know the concept. So this is what, 210, right? Whatever it is, that's 210. All right, so that's technically the concept. Like just transferring like what we already know in math to like words. Let's try to do something else. Let's see. So, I don't know if this one's that complicated. In Michael's class. Oh, okay. Let's do this one, number 4. So not only can you do it with like whole numbers, you can also do it with decimals, right? And then fractions and everything. So let's try to do this one.
3 over 101.44.
Okay. This one's a little bit, it's like a comparison. I'm just reading it now.
Equals.
Okay. So like when we read this, it's telling us which place is a better, like, which one has a better price. So like it's technically just a comparison. So we're comparing ratios pretty much. Like we're gonna have, like whichever one is like a lesser value is gonna be the one that's a better buy, right? Okay. So what was the other one? 5.
5 over 2.50.
Okay. Okay, I want you to tell me which one is a better buy. I'm gonna do the math for this one. So this one you can get 1 for 209. And this other one is like 1 for $2. Which one's a better buy?
The one on the right.
The one on the right, right? Okay. You could actually just do the math as well if you wanted to prove to yourself. This one's greater. Yeah, so this one's a better buy, right?
Yeah.
Yeah. So yeah, that was a little bit like one of those like, okay, a practical one. That's why I like these ones, because then now like it's not much, because like out there you could always, they always ask you like, when do you ever apply math, right? And you're not just like adding like and subtracting on paper. It's like out there you're not using it. Every day you always use math. it's like the tool of like the universe in essence, you know, like everything has math. So okay, let's take a look at this one. Let me see. Let's take a look at how many more are there. There's two more on this one. Let's do 7 and 8. Let's do 7 first. What do you do?
What are the two dots called?
Oh, okay. A colon. This one, this guy.
Yeah.
So this one is like a colon. A colon is just a ratio. This can be written as this guy. Like it's like, and then this can also be written as like 2 to 3. It's the same thing. Like when you see a colon, you can do fraction or you can do 2. But for the most part, I just transfer it to a fraction because that's what we want to work with in math. So what would you do in this one?
2 over 3 equals 18 over x.
Okay, yeah, that works. And then
18 times 3 and 2 times x.
so this one would be 27, I think. Okay, so that's good. And when you put that back, right? Like let me just like look back. Sometimes doing the math is good, but when you take a step back and like analyze what you just did, it's always good. So we found x is 27, right?
Yeah.
So are these really equal? Yes, right? Like they should be. So this is how we know it's 2 and then 3. And then if we were to write this 18, we could technically do this, right? 18 boys to girls. And you can do like 18 boys to girls, 27 girls. And or like 2 to 3. And 2 to 3 is like the base one, the basis. That's the lowest it can go. If you were to describe it usually to someone, you do the lowest. And then like when you're applying it, you're usually given one of these guys. Like when you're like, okay, there's 18 pieces out there. And then I know the ratio is 2/3. Then given that, then you know what the other value is, right? Yeah. There's usually like when I another thing with these is for example like this one, you know how it says 2 to 3, like in a calculator aspect, like and we put 18 over here, and then because what you could do, the fastest way, this is just a trick, right? It's like one of those tricks, like, oh, okay, like I want to do something faster than like the regular way. I always want to put my x up top. So you know, like 2 to 3, like with ratios, since they are a ratio, you can technically just switch them, right? So for me, the fastest way is to multiply than to do any fraction or division, right? You know, that's just for me. Like I really don't like doing other operations but multiply. So what I usually do is, the reason why I put this up top is I could just multiply the 18, right? I could just do this and make it, right?
Yeah.
I could just transfer the 18. It'd be 18 times 3 halves. That's one step. You're not really, you don't have to do anything else. Like it's faster than, okay, doing the cross multiply. You know, it's the same thing. I'm just saying, like there's like if you were doing like a math speed drill, this would be the best operation, putting x on top rather than when x is 1. And then since it's a ratio, you can switch it as long as you're being consistent. Yeah, I think that's one of the nicest things about ratios is you're gonna apply it so many different times, like in probability later on, or statistics, like percentages, all of this. Like it's gonna be one of those things like, oh, okay, you like now it may not, like after this you may not like touch on it for a while. That's actually one of those things that like people like learning this now and then like mastering it is really good, because then you will apply it like, you know, in the end. Like you'll see like the creation of why ratios are very important. All right, let's do this last one.
3/4.
Okay.
And 40 equals 42 over x, or x over 42.
Okay.
No.
X over.
Yeah, x over.
There are 42 marbles in the bag, though. This is the total one. This is a tricky one. There are 42 marbles in the bag. Oh yeah. What do you think you have to do with this one? This is that one tricky one where like, oh, I thought I've been applying everything the same way. Do you remember? You told me you were to add it. You would add it, right?
What?
Like you told me that you should add like red. Like, the very first thing when we had red and green cards, you said you wanted to add them. In this case, you should add them, right? Because it says in the bag. So this what is this? This is the total. So what we need to do like is like, okay, we are given the total number of marbles, but they're not giving us the total number of ratio. So we have to find the red over the total number, right? So that would be the red over the total would be red plus blue over red, right? Like red over red plus blue. And we just will work with what we have here. So 3 plus 4. So that's what, 3/7, right? And then, so that's the ratio. That's the total ratio, not the relative ratio. So what do we do now? This is red over total. Where do we put the x?
On the top.
Okay. And then this is what we have, right?
Yeah.
Yeah. And we do our normal thing. And I think this is 18. So 18 is the red. Yeah, I think we should, that one kind of like slip off my mind. It's like, oh yeah, you could definitely. So there's two ways you can ask this. They could give it to you in relative ratio or total ratio. Those terms are not very common. Like I kind of just make them because like when I mean by relative, it's like one item like to another item. You know, like this guy, red to blue. But then sometimes people like to give things in like the total number. So the trick there is after you're given the relative ratio, you just have to do this. You just have to you have to know what you're trying to find, and then you have to find that ratio over the total for that. Does that kind of make sense?
Yeah.
Yeah. It's just like you have to read through the problem very carefully. It's like, what are you actually given? You're given the total, so you need to find the total. So that's why I think this was the last problem. Because like we were doing pretty much the same thing throughout. Let's take a look at this now. Okay. So you know how like I keep on saying like we need to like build like a system. So when you want to do like solve word problems, you always want to keep that system. Given, find, solve. Given, find, solve. And then right now it seems very trivial. Like it seems very like why do we have to break it apart? Why can't we just jump to like solve, right? Why can't we just solve it? The reason why I don't, yeah, you could just do that. I mean, if you're given like one and then there's another one and then the problem asks you add them, why can't you just add them? Because it's yes, it's simple, but then what if the problem, the word problem, what if it gives you so many different things? You want to be able to build that system. Like, what do I have in here? Let me break that down. Let me write down 1, 2, A equals this, B equals that. What am I trying to find? X. Right now, we're trying to find X. It's very, like, for like, when you see this again, maybe in the future, you're gonna say, oh, you have to find X and Y and Z, you have to, the reason why you want to know that is so that you can refer back to your given. And referring back to your given this kind of like goes back hand in hand. You're gonna build equations, right? And then knowing what you have in that equation, there's a known and unknown. Those are the givens. Then you can manipulate that equation so that you can solve, right? And that's why you want to always keep this in mind, because then so that you don't get confused. You don't want to get confused when you're doing the word problem. You could be solving for the wrong thing. So that's like keeping like, okay, what do I have given? What am I trying to find? And then let me find the steps of solving it. It's always starting easy is always good. So, and building that logic. So I just wanted to touch on that. Let's see. This is kind of similar to what we've already done. Let's just do like one of these. Yeah, let's do like maybe, let's do 12, 13, and 14. Let's start off with this guy. Let's see. Let me just read this. Oh yeah, this is one of those things that you'll really apply a ratio in, is not only like for different item counts, but like conversions. You're gonna be converting like money into, or like different units. And every time you do a conversion of units, you always do a ratio, a fraction. So tell me what you do with this one.
So 4/1.
Okay.
And then x/5.
Perfect. So, and then you just do that. That's the equation. Find x. It's pretty simple because x is 1. So it's 20, right? 20 dirhams. Okay. All right. I think that one isn't that bad. That one looks very easy. Okay. Let's take a look at 13. It's always good to work with, a lot of these are working with money. So later on, hopefully we get to it, but it's kind of like we can talk about decimals of money, which is kind of similar to this. Okay, what do you do with this one?
4/9 equals x/18.
Okay, so this is the B. Okay. Yeah, it's always like what I'm trying to do here is just keeping track of the units. Right now, it's not that bad, but eventually, it's gonna get really bad. Because we're not even doing conversions. Okay, so x would be what? It's 1 and then 2. So that's 8, right? I think it's 8, yeah. Yep. I mean, it's just double, so. Okay, that one wasn't that bad. All right, this one.
1/30 equals x/60.
Okay. Okay, can you hold for a sec? Okay. Yeah, so yeah, that's what you would do. You just pretty much do this 30, 60. And since this is 1, I mean, it's pretty simple. So it's just x 30. So x equals 2, right? It's just pretty much double. All right, let's take a look at something more difficult. Which one is this one? Round your answer to the nearest tenth. Round dollar amounts to the nearest cent. Yeah, let's not do this one. This one is pretty much I mean, you've worked with decimals before, right? Yeah, but like this is just taking it to that like level. Like, oh, do you know how to round? Like, yeah, everyone knows how to round. So let's actually apply this in a more fun sense. Have you heard of like later on, besides doing algebra, you know, all these like operations, you're gonna get introduced to like geometry, which is like, for me, it wasn't fun at all when you combine algebra and geometry. But but like, you know, I mean, everyone likes it to a certain extent. But okay, how you can apply ratios is this word right here, similarity. So let me just define what that means. Hold up for a second. Okay, so similarities is pretty much when you have like these guys. Let me just define what this means first. Come on. So a similar object or shape means like the length of the sides are the same. So any side, you know, like for now, let's just work with like any polygon. It doesn't have to be a triangle. It could be like a pentagon. It could be like a hexagon, rectangle, whatever. But when you're given two shapes right here, you have like these sides, right? And two different sizes. And when it says similar, when something is similar, that means that you can apply a ratio of sides, because they're the same, like similar length of sides are the same. So A from the picture here, right, is pretty much the same, and then as this guy, and then the small b is the same as this guy, and then the c is the same as this guy. So since they're the same, that means they're 1, right? Their ratio is the same. They don't have to be 1, but their ratio is the same. So that's why the division of these guys are the same. And then you can probably think, okay, so now if I'm given like two sides of like one of the small one and then the big one, and then I'm given the big one, I can find the small one, x, right? Or any of these. X can be any of these like 4 things. So that's really a good way of looking at it. Like now you can not only apply this in like money conversion, counting items, you can also apply it to shapes, geometry. So like, see, like that's why I like doing these, because it really shows like, oh, okay, how much can you really apply that math in many ways in life. And in essence, like this right here, especially maybe if you're doing like carpentry or construction, like you can be given like, you know, like a drawing. Like the drawing can be sized differently in like in a unit, because it's a small paper. You don't want to be sizing things in real life. And then so when you build it, it will be this big guy, right? When you build it, it's that big guy. So knowing that ratio, you can definitely build it because you have that ratio. So that's how, yeah, that's how I would see like why a lot of these are very interesting, because it's like, oh, not only for similarities but in construction, you know. So let me take a look at this. So let's try to attack number one. What do you think you would do? Like, I'm just gonna ask you because I can't explain the theory, and now let's try to apply it. What do you do to find an x here is this guy? So this, okay, maybe I'll just go. This long one right here is the same as this guy, right? So it'll be 5/15 equals, and then let me take a look at what this is. So I'll just put that somewhere where I think is like appropriate. I'm gonna say over here, or let me take a look at this. You have to be consistent because then this is 15 is at the bottom. So bottom would be like the real guys, the big guys, and then 5 would be, so the small one. So that's relating to what? 4, right? So you just have to match where you think they are. So that this long one is the same as this guy, and then this one is the same as here, and then this one is the same as this guy. Have you guys touched on like the name of the triangle sides?
No.
Not yet. Okay, that's why I'm not saying them. There's like there's names for them. Like the biggest slant, this guy is a hypotenuse. But let's not talk about that. And then for a triangle, the smaller ones are called legs. So hypotenuse and legs. It's always good, like to preview them, right, so that you know it when you hear it. But to apply it, did that make sense though? Like you just have to match the sides, and then be consistent with like what you're trying to equate that to. Like the bottom would be the real, or the big one, and then the top would be like the small one, or the drawing. So after setting this ratio, you just plainly do the math, right? You just do the math. And then that's what you get. Like you just, and it's 12. This guy is 12. Let's try to check if the ratios are all equal, like what we did here. Just to like prove to ourselves, like, oh, it's like that must mean it's not just a theory. It actually applies. So how you would do this is, and it's also practice for matching them. So like, let's take a look at the smallest leg first. So 9 is, and it'll do small to big. So that's like 3/9, 4/12, and then 5/15. And then these are all 1/3, right? Yeah. So the theory is right. The ratio does work for similarities. They're all the same ratio. So that's pretty interesting, right? Yeah, like like just knowing how to do like the fraction and the ratio allows you to do this. So let's try to see if we can do another thing. Okay. Let's try to do, this one isn't that bad, because like their sides are pretty much, 2 of their sides are the same. This is the same. Usually the way I to like mark to myself which ones are the same. I didn't do it for the first guy. You could do this, like 1, 2, 3, 1, 2, 3. And you can match where they are, So how do you find this guy?
9/3 equals 6/3. Wait,
Yep.
6 over x.
Okay. Right. Yeah, that's pretty good. So that's like what, 18. So does that mean it's 2? Yeah, it looks about right. Okay, so that one wasn't that bad. I think we probably need, let's just do number 3 and then number 4, just to like keep, so that the speed is faster. Okay, what do you do to get this done?
12/4
Okay.
equals 15 over x.
Perfect. That's good. So that's 12x. So that's 60, right? 0, 2. Yeah, that's 60. X, or whoops. So that's 5. Okay, so that's not that bad. All right, let's do the last one on this one.
32 over 8 equals 60 over x.
Perfect. Yeah, good. And then this is 480, and you divide it. What is that one? 15. Okay, that's good. Yeah. So what do you think of that? That's not, is that interesting or is that not too bad? Not too bad. Okay. But you can see how it applies now. Let's look at if these are the same. I haven't actually looked at the word problems. See, like doing a picture is, I think it's like so much easier. Like you could technically transfer this picture to a word problem, and but then it's up to you to draw the picture. Every time you do, you're given a word problem. Sometimes it's not as easy to see if you don't draw a picture. So that's another strategy. Besides given, find, and solve, draw a picture. Like, and that's part of your given. Okay, let's take a look at this one. Just to check, let's do number 7 and then number 8. The number 7 first. Okay, so this is kind of like a construction one. Let me see what it says there. There's a shadow. So there's this shadow, okay. And then so there's a shadow here. And then there's the actual length of the girl. And then he wants you to find the actual length of the building, right? So what's the ratio looking like?
24 over 5.
Okay, so this one, they kind of play a trick on you because they gave you the building first. But then you're actually looking for the building as well.
So 5 over 2.
Yep, yeah.
Equals 24 over x.
So the shadow, right? This is the shadow. And this is the real.
Oh, x over 24.
Yep, okay. So shadow, 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 real. Okay, that's good. And then you just do this, and then that's what, 0, 2. I know I can do that one. Okay, that's number 20. Okay, x, 2, that's 60. Okay, 60, that's good. All right, let's do that last one for this one. So this one is kind of like a map thing. It gives you that, and that's like on a map. Okay, and then the real distance, he gives this to you in inches, which is good because you know the ratio of inches to miles. But the real thing is inches, and he wants you to find it in. It doesn't tell you, but he wants you to find it in miles. So what does the ratio look like?
2 over 14.4.
Okay.
Equal.
So this one is when you're given the like this ratio already, they should be together because they're like given together.
So 2 over 45.
Yeah, and then I guess I'll write their units just so that it's easier to see, and then over what?
Over
Like
14.4. 14.4 over x.
inches up top, miles on the bottom. Writing the units helps, yeah. Like if you write the units, you don't have to think which one goes with which. Yeah, so and then like so you just do this one, you know. And whatever this is. So what is this in miles? It's 324. Okay. Yeah, I think that was fun. I honestly like these problems can get really hard and more complex, but then you're just applying the same thing, right? They're gonna change the units on you. If they change the units on you, just keep the units like whatever they give it to you. Just kind of like track which one is real, which one is the one that's a scale. So sometimes a ratio can also be referred to as a scale, like scaling it down. Like for this problem right here, you're scaling it up, right, from a map. Yeah. So yeah, like similarities is like one of those fundamental things that you can apply a ratio. We don't have to do this one. This one is just kind of similar. Let me just see if there's something different. Nah, you can do this for practice. What about this one? Similar figure word problems. To answer yours now. Centimeters. Nah, this is kind of similar to what we did already. Okay, let's move on. Okay, so this one, you know how like I said like you can apply ratios to money, and then you could also apply like percentages and like interest rate. Have you worked with I'll just define it like sometimes in a word problem you have to apply an equation that would be given to you already, right? Like you have an equation, and then your teacher's going to talk about like the theory of the equation, how it got created, and then the word problem here is just going to apply your equation. And then let me just explain like one of those, like this is just a sample thing. I've seen this a lot actually, like after learning percentages, rational numbers, as well as like fractions, all of that is the concept of, it's pretty much just a concept like applying like what you know already of like interest rates, and an interest rate is just it's just a part of 100, like something's over 100, right? So like if you have like a 4 interest rate, 4%, that's 4 over 100, right? So 4%, and sometimes it gives it to you like 7%, 10%. When you're doing percentages, everything is over 100. So that's just what definition of an interest rate is. And then that interest rate is going to be, when I say like simple interest rate, we're not going to cover this other guy because this one gets complicated. Let's just talk about simple interest rate, like interest. And this is what this is: simple. This is simple interest. And then this is just a way of applying like fractions, because then this guy right here is a principal, and principal just means like, for example, if I gave you like $10,000, right, and then I tell you invest that's your principal, and then this interest can be like, okay, I give you 10%, and this 10% is like 10 over 100. This interest rate this is how much this guy can grow. Like the theory right now doesn't make sense. I'm just like trying to explain this equation, because we're just gonna apply it, and then because you are gonna see this in a word problem is so you have money, and then you have an interest rate, which can be like a fraction, and then this t can be like, because when you have money, right, and then you kind of invest that money for like, you need to have a length of time. So 1 year, 2 years, 3 years, and then that 3 years is just going to be how many more times that this guy can grow, that this 10,000 can grow. Because like every year, that's why you're timesing this. So you do like 10%, and then how many years? 2 years. You just pretty much, this is how you apply this equation. You just like the money, and then you have the interest, and then you have the total number of years. And then I would say why this is like a rational concept problem is you're gonna be just multiplying them, and then you just have to apply this equation, knowing what this equation is. Sometimes they give you the principal, sometimes they give you the interest, and then they give you the total, and then you just have to find the interest. And okay, let me try to does that kind of make sense? Like that's the simple interest. And then so when you times this though, like when you times like the money, when you times the money by the fraction interest and then the number of years, you're only gonna get a portion of your money, right? It's not like, oh, okay, so that's why it's an interest. It's like how much your money grew. So it's like it's that thing, a portion of 100 that's gonna grow. So that's like the interest, you have to add it to your principal. So your total, like after like maybe 5-10 years, I ask you, how much money do you have after investing $10,000 at 10% interest for like 10 years? Then you would say what I started with plus the interest, right? It's what you started with plus the interest. Does that kind of make sense? Yeah, it's not that complicated. It's just that like, okay, so that's how you apply it. Like you have the interest, which is a part of how much you invested, the money. And then when someone asks, how much do you have? Because when they ask you for your interest, it's just a portion. When they ask you for your total number, it's adding your interest to how much you invested, which is the principal. Okay, let's this is kind of like the last part, so we can go slow on this one. It's not that bad. Let me rewrite this equation. These will be the two equations that you'll need pretty much. Simple and then total. So let's take a look at this guy. I think there's I'm not gonna do that one. We'll just take a look at the simple interest. So let's do number one. So number one, what are the givens? You can still do givens there. The givens, it gives you the principal, right? And it gives you the interest rate. Interest rates are usually given in percentages. It doesn't tell you what it is, but it says it's a percentage. And then total number of time usually in years or like months. So you're given what? You're given P, which is the principal. You're given the interest, the percentage. Maybe I'll write it down here. Like this is the principal, this is the interest, and this is the time, right? And then what are you trying to find? S. It just wants you to find the S. We can find the total, but let's not do that for this problem. Maybe we'll do it for the last one. Okay. So you're always wanting to find the S. And then also, I didn't really like explicitly say this, but when you're working with word problems, it's good to lay out your. You don't want to be having your variables be like a long name. You don't want to be like, say, simple equals, you know what I mean? Like principal times interest, right? And then time. It's just too much. Like what you could do is like as a given, like when you say given, you can say like S is simple interest, and then P is my principal, right? And you just write down what they mean, right? In the beginning. And then T equals like time. And then after that, you can say like S equals P times I times T. That's your equation, right? And then maybe you're given, for this problem, let me just set that up for you. Like, so you're given P, I, and T, right? So you're given P, I, and T would be like 3,400. Let's not put the units. 3,400 And then what about I? 4%. Is that whole number? It's not a whole number, right? It's what is the percentage?
4/100.
Okay, good. So that's what that is. It doesn't tell you explicitly, but it just assumes that you know what the percentage means. And then so total 3. So now, and then what are you trying to find? Finding the S. So let's try to solve this one. So all you have to do is apply the equation. Just apply the equation. So what was it? P times interest times total, right? See, like the way that what I'm trying to explain here is you can do this really easily, or you can set this up. And this is the way I usually set things up, is from like a word problem. I want to know what my givens are. Set some variables, right? So you don't have to keep on writing long things. Give the equation, and then put your givens from the problem, and then the find. See, like this is easy because you're just finding this guy. Sometimes they could give you the S, and you have to find the time. You give you S, P, and I, and you have to find the time. So you have to manipulate the equation. But this one, you don't have to manipulate anything because it's given that way. So, and then the last thing is just doing the math, right? Last thing is, okay, perform the math. So what is your interest? So let's just look at this. And this is your interest. And this is less than what you had, right? So if I were to ask, I guess now let's try to ask, what do you have? Like, what is your T? What was T?
3 years.
Oh, shoot. I made a minute. So this should be total money. Let's not make that T. Let's make that M. So what is the total money you have in the end? It's P plus PIT, right? So what did you begin with?
3,400.
Okay. And then what was your interest?
4%.
Like the interest, not the rate, but the simple interest. This guy.
4,092.
Yeah, because this is this guy, the simple interest. So the total money you have in the end is the money you started with plus the interest. So look, you gain, this is how much you have in the end. So that's not that bad, right? Like it's just applying, percentages, and then like, I guess this is addition, multiplication. But in actually, it's just applying all the different things. And mainly that's really, like when you're solving like a word problem, a lot of it is just like having an equation that you have to work with, and then like setting up your givens, find, and then solve. And then, what I just did there, like if you don't know what you're solving for, if you write down everything you have, and then kind of like pinpoint, okay, I have P, I have I, and T, so I don't have S, so I must be finding for S. And then if I don't have the equation, you can always rearrange this equation. Okay, let's try to do, let's do a harder one. Let's do 9. Let me zoom in and erase that. Oh, jeez. 9. So find the S and the M. Here, I'll show the equation. So what is our P, I, and T?
The P is 7,400.
Okay.
The I is 10.5 over 100.
Okay. You should just write it like this. And then what is your time?
A quarter of a year.
All right. 0.25. All right. So how do you find your S?
P times I
Okay.
times T.
Okay. So we don't have to manipulate this. It's already given to us, right? So really easy. You just times it. I'm just gonna do this one so that we can move on to the M. So what is your simple interest? Simple interest is 194.25. Okay, now what is your money after the interest and that amount of years? How much do you have in the end? What do you do?
P plus P times I times T. So P plus 194.
Yeah. Yep. So P was what?
7,400.
Okay. And then S is this guy. So how much do you have in the end after that interest for that amount of years? You have 7594.25. So, I mean, the concept here is that your interest is less than your P, your principal, and then the amount of money you have in the end is just adding your interest to your principal, right? The amount of money you had in the beginning. So yeah, that one isn't bad. What do you think of that one? That's just a way to apply everything. And an equation, writing an equation from like a concept. What do you think of that?
Like, good.
Do you think you can, if you were to, because you might see this again. I'm not gonna cover compound interest. Have you guys worked with exponents before? Okay, because compound interest, like in when we're talking about like PEMDAS, you remember that, right? Like there's this P is like parentheses, right? And but then this E is like exponent, right?
Oh yeah, we're the little numbers on the top of
Yeah,
the
like this guy. When you have like 2 squared. So what is 2 squared?
4,
Okay, so yeah, you work with it. What is 3 squared?
9.
Okay, maybe we could work on this one. uh, maybe we'll cover it next time because I do want to cover this other part. We'll review a lot of these and then see what else you guys do throughout the week. We'll cover that next time. When you're working with, because like the one that we did today was simple interest. The one with the exponent is compound interest. Compound interest, the equation is not so simple. It has an exponent. Okay, let's take a look at this one. Yeah, this one has simple interest as well. You could probably work on these ones. But the one thing I want to like cover are the word problems. With the time that we have, let's do all of them if we can. Let's just do number 11. So now it's actually a word problem. It's not just and then it's applying the simple interest equation, which is this guy.
So we don't have to solve the M.
Let me see. What does it say? What is the value? It depends on what it's asking. What is the value of the car 1 year after the purchase? Oh, what is the value of the car 1 year after the purchase? It seems like you have to. Yeah, this one says value of the car after the purchase. And then this says, this is a little weird. I didn't really touch on this one. it says depreciate, right? And that's one of those things like you have to take a look at. It's like, oh, what is the problem asking me to do? And certain keywords kind of tell you, like this word, what is depreciate? It means not to add it. Like it's going to manipulate this equation. It's going to be minus the interest, right? Because it says depreciate, which is opposite. So it's not like appreciate. It would be appreciate would be positive, depreciate would be negative. Let's just see if this is what this means. So what is the interest?
The P is
Yeah, what is P?
28,000.
Okay.
The I is 9/10.
Okay, I'll just do this.
And then 1 year.
1 year. Okay.
The T is 1 year.
Yep, it says it 1 year right here. Okay, so the S is gonna be, I'll just do this one. Maybe I don't have to times it by that guy. So that's 9%. So that S value is 2520, which is good. And what is, so now it's asking you what is the value of the car after 1 year, right? So it's gonna be the M. So what is that value?
28,000 minus 2,520.
So 25 or 28 minus 2520. What is that one? Let me just write this down and then explain why this is the case. So the answer is 25,480, right? Or this one.
Wouldn't it be like 3,000?
It says what is the value of the car 1 year after?
I thought the M was 25,000.
Oh, the M? No, like 28,000 minus 25, right? 28,000 minus 2520. What? So the S here is 2520, and then 28,000 minus 2520. And the reason why we're minusing this is because, like I said, it's like in a real sense, you can tell what it is. Like after you buy I mean, later on, you know, when you buy a car, and then a car always like it loses value, like over time. And then so that's why here after you buy it, after 1 year, the value is less than when you purchased it, because like this interest rate time, the more time you own that car, the lesser value it is because of this depreciation. So yeah, this one, what do you think of this? It's kind of just like, yes, we talked about adding the interest, but then this is more like a real world application where, okay, for a car, the value actually decreases. It never increases. It always decreases. So that's why we're not, for money investments, you add it. And then for like cars, value of cars, you always minus this S. Like, does that kind of make sense?
Yeah.
Okay. Yeah, so that one is like I said, there's a lot of ways a problem can be asked, but you just have to like be careful, like, oh, what is it asking you? Let's do this one. This is 1 5 actually left money. This one isn't that bad. This is just going back to the money thing. So what do you do?
The P is 4,000. The I is 5/10. And the T is 5.
Okay. T is 5. Good. And what is it asking you?
How much interest does Sarah get at the end of those 5 years?
So you have to find the S. Okay. So not that bad, right? You just times what you have. I'm not gonna even write the numbers. I'm just gonna write the answer. So in the end, the interest is timesing all that. All right, let's move on to 13. That wasn't that bad because we already did. We were used to doing that already. Let me just read this one. And if you deposit, I don't really like this one because it's still kind of the same thing. Maybe not do 13. Let's do. Okay, this one is the fun one. Let's do 14. This is asking for how many years now. So you have to find the what?
S.
For years.
Oh, year.
Yeah. This is the equation. So which one are you trying to find for years?
The T.
Yep. So this time you're finding the T. So now we finally, like, we've been always applying the equation, like the way it was like created, but it doesn't have to be asked that way. And for the most part, it will never be asked that way because like in the beginning you're going to be using it, but then once you apply it, they can mess around with you by like giving you different things. So you have to manipulate it, right? So now the T is just the simple interest divided by the principal times the interest. Okay, tell me what goes where. Like, what do you do?
The P is would it be 2,000 plus 400?
For the principal?
Yeah.
It would just be this guy, because it tells you what they are in here.
The P is 2,000. The I is 5/100.
So it says here per year. Simple interest. Let me just read this first. So 400 interest would be 400. The principal is 200. 2,000. I see. They're messing with you. It's actually this guy. And it's just this one. Right? It's the interest, the simple interest, which they already gave you. The principal over the principal times the interest rate. And then you should be able to get the T, right?
Yeah.
Okay. Let's see if that's the case. 400 divided by 2,000 times 0.05. And it tells me this is 4 years. Sounds about right. If you look at it says 4 years. So like, just to kind of like, we don't have to cover the other ones. So the rest of it, I just want to talk about this. Like how you know that your equation is correct. Because like, if they're giving you this equation already, that for a fact it's correct, right? But the moment that you try to manipulate things, it gets kind of like confusing. So the way I usually look at it is look at the, look at the units, and then the units should make sense in the end, right? And what I mean by that is like, so S over P, these are just variables, but they also have units. I'm just gonna write them in brackets. So this is in years. This one is this is in dollars, and this one right here is in dollars, right? And let's see. Whoops. This is actually your simple interest is dollars per years. And this other one is, it's just a percentage. So there's this is none. There's nothing here. Okay, let me try to explain what I'm doing here. So let's see. Percentage per year, okay. Oh, okay, there you go. That's what I'm trying to do. Yeah, that makes more sense. Okay, so when you're talking about the simple interest, and just using this as an example, this one is given in dollars, right? And then also the principal is always in dollars. Both of them are always in dollars. Principal and S&P, principal and simple interest. So, like looking at this equation, this is gonna cancel out, right? So you're left with what? 1 over years, right? So what is that? 1 over years is the same as years. Years over 1, years over 1, right? Times the whole thing, Matt. You're gonna be equal. You're gonna have years up top. So this is correct because this equation is the time in years equals S over P times I. And then the units match, right? So that's a way for you to like check if the units match, if the equation that you have is correct. Obviously, like when you do the math, it doesn't really inform you, like if your answer, because then you sometimes wonder, what are the units of my answer? And that's a way for you to figure it out. Like here, it's not hard, but it will get harder when they give you like all these units, and sometimes you have to convert them. And then when you don't convert certain things, and then when you multiply them, it doesn't really, if the units are not the same or the way they were formed, you're gonna get the wrong answer. So, I mean, right now it doesn't matter. We'll talk about it once when we get to it. But yeah, like just talking about this, there's like so many different ways that you can, I think we're pretty much done today. But like when you're applying like all the math like in word problems, there's so many different ways that you can like set them up. And you can just pretty much like maybe answer the question, and then knowing the math, like, and you can like kind of like do the mental math of like, okay, I already know what I'm gonna get. But in the end, if you have like a system, that tells you, okay, get the givens, get the find what you need to do to find, and then set up the procedure. And then sometimes you may be given the equation. You could always manipulate it the way, or this can also be this guy. Many ways, right? And you can have like you could do this in so many different ways. Like you could look for the S, the T, the P, or the I, and you could be given any of these, the givens, and you just have to find different things. But you always have to like kind of in a way like know what your givens are, and then kind of set it up so that like your equation tells you what you're trying to find. And then plug in the values, the givens, so that then you can solve the problem. And then all of that can be applied to any math problem. But like that's how you do like a word problem in the end. Like the word problem can change depending on like what subject you're applying it to. Markups, discounts, money, construction, whatever it may be, right? Like fruits, items, all of that. But as long as you like set it up the way that it's easy to understand, then I think you're good. What do you think of the system? Do you think you can apply it?
Yeah.
Yeah. It's not bad, right? It's like looking at things in a. Oh yeah, and then like setting up your own variables. Do you think now if you were to read like some of the word problems, like it's just a theory. Like the reason why like I or anyone can't like set up the equation, if you can't set up the equation, it's because no one told you the theory yet. Like after someone tells you, okay, this is the theory, this is how you apply the equation, and then when you apply it, okay, they're gonna give you different like givens, and you have to find it. Then anyone can do it, right? All you have to know is the background and the equation, and everything. And I think like when you get to learn like advanced mathematics, that is what it is at the essence. Like if you break it down, this is it. This is all of it. Every problem in like math, a word problem can be broken down into just setting up the equation, finding what you need from the givens. It's pretty good, right? Like when you like, because like if you just jump into like solving the equation, sometimes you're gonna get confused, because it's not just one step. Sometimes you have to do one thing, and then because of that, then it branches out. Should I do this, and that? But if you write them down, 1, 2, 3, this is my procedure, then you can like branch it out, like for this one, this gives me this, or maybe I have to do this. And after I do this guy, it will lead me to my final answer if I plug in that value, you know what I mean? Like, and that's just like, messing with the equation and yeah. So I guess, yeah, next time, next week, let me know, or let your mom know what are things you guys are doing for class. Hopefully it's like more exciting stuff than fractions. Okay. All right, Milo, I think that's pretty much it. Yeah, I think we don't have that much stuff today, but what do you think of that? Do you think if you were to do practice problems, you can master that like this month or this week?
All of them?
Not all of them, like one by one. We're gonna cover them again next week if you want to. Do you want to do that? Like same thing next week?
Yeah.
Okay. Well, we'll just do the same thing. I'll find different problems that's gonna be within same topics. Okay. Milo. I think I don't want to, like last time I went overtime, so I'll let you go early this time. All right. Have a good one.
Bye.
Yeah. See ya.